Okay, so we're going to do 4.1. We had already started this in class, so I'm just going to pick up where we left off. We already did a degree minute second sample, okay, and it is page 321 in your book. If you have questions, I mean, if you need to see it again, or if you didn't get all those notes. Okay, so now we are, and we had done an arc length, but I'm going to just write the formula for arc length for you. Now your book's got a couple, but I like to think of it as the portion, okay, of the circle times 2 pi r. All right, so let's do one more example, because that one was kind of rushed in class today. Let's see here. You have so we have 60 degrees slice of a, so we have 60 degrees slice of a 7-inch radius pizza. Okay. And the arc length, so the crust length and area of slice. Okay. Well, if arc length is the portion times 2 pi r, then the pi, like the, what is that called? A sector area would just be the portion times what? Well, circumference is 2 pi r. Area is pi r squared. See, that's why I don't like to write the formula they give you, because this makes more sense. Like, oh, it's just a portion of that. And this is a portion of is multiplication, that. Okay, so for this one, the arc length, which we call S, okay, little s, and then the sector area is a big S. Okay. Anyway, the arc length is, I just like to write the word, is a portion. So that's 60 out of 360. If it was given to us in radians, I would do the radians out of 2 pi. Okay, so I'm going to write that in my other color. Okay, so then if it's in radians, I would do radians out of 2 pi. Because that's, again, a whole circle. Okay, all right, and then times 2 pi times 7. Okay, and then you just do that in your calculator. And so you get 60 over 360 times 2 pi times 7. And I get about 7.3. So I'm going to change these to squiggles. 7.33. Now it's arc length, so it's going to be inches. All right, and then the sector area is the portion. So again, 60 out of 360 times the area. So pi r squared. So I'm just going to hit second enter, so that brings that up. And then well, actually, I think it's more trouble than it's worth. I'm just going to do it again, type it again. 60 over 360 times pi times 7 squared. And I get about 25.66. And then this is inches, but it's area, so it's inches squared. Okay? All right. That's that one. And then now I'm going to do a unit conversion question, which is actually angular speed. okay? But angular speed is really just like what speed is something moving in a circle, okay? So there's not so much of a formula for it as just a unit conversion problem, okay? So let's write it out first. It says a truck has wheels. That's good, it has wheels. 36 inches diameter. Okay. If the wheels are rotating, rotate at 630 RPM, which stands for revolutions per minute. Find the truck's speed. In miles per hour. Okay, so this is entirely relevant. If you can say like how many times, like if you're riding a bike and you know how big the wheel is, right? And then how many times around you can get that thing in 1 minute, okay? Which is just a counter. You can like buy a counter to put on your spokes of your bike, okay? And you can also, then that's how it converts it to your speed, is it's literally just counting it. Or in your car, it's counting the rotations of your axle, okay, and per minute, and then converting it to miles per hour, okay? All right, so let's do this. Let's start with 630 revolutions per minute. Well, okay, let's write that out. So this is 630 revs per 1 minute. And I like to write it in this way because we're going to kind of do the unit conversions. Okay, let's worry about the revolutions. I'll worry about minutes later. All right, so revolutions. I want to get rid of revolutions, so I put that on the bottom. All right, and then what can I turn that into? Well, if I turn it into degrees, that's not like really related to a length, but radians are directly related to like a radius, okay, or diameter. See, okay, so it's directly related to the radius. So I'm going to do 1 revolution is 2 pi radians. Okay, where did I get that? I don't know why I wrote the whole word radians out. That was silly. 2 pi rad. Okay, where did I get that? Well, think about it. 1 revolution means all the way around the circle. Well, that also means 360 degrees or 2 pi. Okay? All right, so now the revolutions cancel. Now I want to get from radians to the radius. Okay, well, the radians and the radius are proportional. That's like the definition of a radian. Okay, is that, let me see if I can find it in the book. Give me 1 second. I just want to write the actual definition for you. Okay, so over on the side, okay, 1 radian, so a central angle of a circle has a measure of 1 radian if it intercepts an arc with the same length as the radius. Okay, so 1 radian equals the arc of the same length as the radius. Not pi radians, 1 radian. So if I've got a length, if I've got a diameter, I mean a radius this big, then if that was a piece of string and now I stretched it this way, so let's see, this is about 1, 2, 3, 4. 1, 2, 3, 4. Curved it this way. See, this one's about, like, this is the same length. Then this is 1 radian. If this length is equal to this arc, okay, then that makes 1 radian, no matter the size of the circle. If I rotate until my arc, and that is equal to the radius, and I stop, that's always 1 radian, okay? All right, which is why 1 full circle makes 2 pi, okay? Because the arc length and the radius, okay, the circumference is 2 pi. So I want the radians to be the same, so that's 2 pi, okay? All right, so 2 pi radians. All right, and so now I can get rid of radians. Radians are equal to the radius. Okay, well, they're proportional. So 1 radian, not pi radians, 1 radian, okay, makes half of the diameter, or the radius, okay? So that would be half of the diameter, which is 18 inches. Okay, let's write that Y. Because definition of radians. Okay, same length as radius. Okay. All right, so then now we got it. Inches, now I need to turn inches into miles, so that's fun. Well, inches, I know how many feet are in a mile. It's 5,280, but if you don't, then that's okay. You can just Google it. All right, so, or I will give it to you if you need it. Okay, so 12 inches makes 1 foot. And then 5,280 feet. Oops, we're going to cancel inches. Makes 1 mile. Okay. All right, so now I've got miles per minute. Okay. Well, so now so I'm good there. So I'm going to stay with that. And I kind of like to circle it so I know I'm done with the top. Now this is not okay. So just kind of keep coming from here. So now I want minutes to cancel up here. And I need hours. So minutes to hours. So let's go straight there. So there's 60 minutes in 1 hour. And then that's it. Okay. So now I just do it with my calculator. Okay. So I'm going to do 630 times 2 pi times 18 divided by 12 divided by 5,280 times 60. And I get 67.47. I'm just going to put 5. And you know, if you have to drop down here and keep going because this was in the way or whatever, that's fine. Mine fit like perfectly in there. Okay, but you know, it might be even better if it was like over here because it goes with that. Okay. So I think I'm going to move it to when I'm going to look nicer. Okay. Alrighty. And then that is all. I'm going to do one quick degree minute second one, but if you understand those, then you can just stop the video now. But just in case you needed one, review one. Okay, so I'm going to do convert, and I already did this one in class, okay, but just in case, so, all right, I'll do another one. So I'm going to convert 21.32 degrees to degree minute seconds. Okay, all right, so this is already 21, so that's 21 degrees, done. Now I just take the 0.32. So over here, 0.32, okay. What is this? This is degrees, so I want to get rid of the degrees and turn it into minutes. So there are 60 minutes in 1 degree because the degrees are just like hours. And so we just do that, okay? So then 0.32 times 60 is 19.2 minutes. And we put a little, remember that's the symbol for minutes. Or you can just put a capital M, okay? And then now I'm going to slough off the 0.2, and that's minutes. And then minutes, cancel here. And there are 60 seconds in a minute. So then you just do 0.2 times 60, which is 12. Sorry for the weird, like the extra numbers and stuff. I mean, these extra symbols. They use capital D, capital M, capital S, or degree, and then that symbol, which I know is normally the foot symbol, but it's a minute symbol here, okay? And then this is seconds right there. Okay? All right, now let's convert a degree minute second. So I'm going to do with 48 degrees, 30 minutes, and 36 seconds. Okay, so 36 seconds times seconds into minutes. There are 60 seconds in a minute, so 36 divided by 60, and I get 0.6. And then I'm going to use 30 minutes and minutes to degrees or hours, right? And there are 60 minutes in an hour, which you already know this is going to be 0.5. I'm just showing you. Okay. Then you add these together, okay, and you would get 11, so 1.1. Okay. And then you got it. So now we've got 48 point something, but then this is 1.1. So it's actually 49.1. Okay, 49, where did it go? Maybe I just made it up. Okay, anyway, 49.1 degrees. Okay. Wait, what did I do? 48, 30, 36. 36 seconds. Oh, what am I doing? Sorry, just kidding. Didn't feel right, which is why I was like, I need to check my work. But then I figured it out. Okay, so this right here, I stopped at minutes. You can't stop at minutes. You got to go all the way to degrees. That's the whole point. I'm trying to turn this into decimal degrees. So let me just back it up. Slow roll. So seconds, I got to go from seconds to minutes, but that's not it. Or you could stop right there actually and put it here and write 30.6 minutes and then turn those into it. But I just go all the way. So then now this is minutes to degrees. There are 60 minutes in 1 degree. There we go. So you take your seconds and divide it by 3,600, your minutes and divide it by just 60. So 36 divided by 3,600, which is obviously 100th, right? So 0.01. Now combine these and we get 0.51 degrees. Okay, so altogether we get 48.51 degrees. Okay, I was like, that doesn't work. You can't get a whole degree out of these because those are both decimals, like they're portions of degrees. So, okay, that makes better sense. Alrighty, so that is all of 4.1, and then you have assignments to do.